gosh, there'll be no questions.
Are we in shock?
What's that? I know. If I had to do it all over again. Well, I think as with anything, if we were 20 years younger knowing what we do now, what would you do with your life? You know, that's kind of what we have now. And if we had to do this one over again, I would definitely capture more data during the design sessions. You know, we captured the basic stuff. You know, we captured, this is a camera, this is the resolution, this is the frame rate, this is what it supports in terms of reference, but we didn't really do a deep dive. You know, does it support -21 and what level? Is it 30 and what level? You know, capturing more data at the design sessions would have probably been the biggest thing I would have changed on that one.
And for the panel also, if you had a greenfield facility you wanted to build, how would you choose between going SVIP or SDI? What would be your decision? Could you repeat the question?
Okay, so if you're a greenfield and you had to choose, do I bite the bullet and do IP? Do I build more SDI? Do I build SDI? You know, it depends a lot on your business goals and your scale. The way I see it, systems that are below maybe 512 squared HD size and don't have any pretension to doing UHD in that design, you know, it's small systems like, you know, it's quote small systems like that. SDI is incredibly cost effective right now. It's mature, it's been cost engineered to death. So, you know, in smaller systems, I'm going to boldly agree with David Ross. There's not necessarily a drive to do IP just because. Now, that said, if you start getting bigger than 512 square, or you have any pretension of doing UHD or high frame rate or anything like that, then suddenly IP is where it's at. But
yeah, go for it.
Well, having seen dozens, I would say, of RFPs over the last 2 years or 3 years related to do we build an IP facility or do we build an SDI facility? You know, I would say probably 2.5 years ago, you would get a question from either a consultant or from an potential end user that would say, tell us what it costs to do it in SDI, tell us what it'll cost to do us in IP, tell us what it'll cost to do it in both, you know, and give us every iteration possible in the system. And we would literally spend hundreds of man-hours generating costs for things we frankly had no idea what it was going to really be. We had to take our best shot at it. In the last year or so, year and a half or so, looking at RFPs that are coming in, people are starting to understand and address the technologies and know a little bit about what 2022 and 2110 and so forth are. And it changes the architecture and the complexion of what you actually ask for a bid going forward now. The weird part about it is I don't think we are at the point that you can say IP is necessarily cost effective if you put all of the costs involved in a system. That means the training of the staff, the support staff. Are there enough vendor manufacturer support teams out there that can help be on site for a year, literally a year in some contracts? If it's a sporting event or stadium, we see contracts, our commitments to not only be there, but also the vendor's requirements to be there for every single game particularly a major league national game of some form. So, and there's a lot of parts and pieces to that question when you say, is it IP or is it SDI?
We always ask the question, why do you want to go for IP? As I said, very often the answer is we think because it's cheaper. Very often it's not. When you take all the costs into consideration, it might be cheaper over time. The other aspect I just want to mention is we ask the question, how dynamic will the infrastructure be? Because there is a reason why you go for IP. It's not the cost, it's about the agility, the flexibility you can achieve. If the customer comes to us and says, I will build it once, it will not change for the next 5 years, so why do you want to go for IP? Maybe the CEO told him it has to be fancy, it has to be IP. From a technology point, there is no reason very often. So if you want to be agile, if you want to be flexible, this is where you save money over time when you do something in HD today and you want to go for UHD in 3 years and you know you will do it, then go for IP. But when you know it will stay for the next 10 years like it is, then probably don't do it today.
But I'd like to ask our friend from the audio world. So, the audio industry is a few years ahead of video on doing everything on IP, maybe with a few technology false starts in there. But how's the experience now? Do people build IP just as a standard practice, or is it still a value exercise?
Well, that's quite interesting because I suppose you can cut the market in two, really. I mean, you say the audio is ahead. I think in certain ways it is, and if you look at the radio market, that's certainly true. People are doing things in the radio environment, mainly because they don't have to worry about video too much. That we're only starting to think about doing in a video-based complex. So for radio, certainly the ideas behind it and the agility, the flexibility that IP provides in terms of joining facilities together, utilizing that sort of flexibility, moving signals around wider infrastructures from site to site, that sort of dynamic nature of what people are doing in the radio environment is very attractive. And going back to your point about the business environment for that, I think a lot of it has to do with that business environment. So we're now talking to people who are designing infrastructures in ways that are very innovative, in ways that they hadn't really thought about doing before. Putting operational centres in remote locations, for example, reducing the size of those production environments, maybe working towards almost a work from home way of working, which obviously over a longer period of time is going to have significant impact on the costs involved in their business.
Great. So I always feel like whatever happens in radio 3 or 4 years later will happen in television. So
yeah, absolutely, I would agree with that.
Yeah, my question is, at one point one of the presenters said introducing a incorrectly configured device into the network would bring the network down. What is actually the process of, let's say, getting a new camera introduced into the network?
At least I can talk for our cameras. It really depends also on the network infrastructure and how the access control is. For us, very much to your question, which by the way has actually been a very important part we've learned, is not allowing rogue devices on the network at all to cause problems has been really important. So there's a couple of things we've done. Is first off, we do a default deny on all traffic on the network. So you can plug anything in on any IP address and any misconfiguration you want, nothing's going to happen. Now the SDN control layer, whether it's ours or another vendor's, can say, hey, we're expecting this device at this IP address on this port, now let's that allow. So in terms of configuring the device on the camera, you have to do a unicast address on the actual port itself. So unicast is that's allowed to set up the ARP tables and all the routing tables, that kind of stuff, and a subnet, just like you normally do on any network device. Then you address multicast ports and multicast addresses for every payload you have on the device. So in the camera, you're going to have a multicast for the video for your main feed. Maybe it's a UHD, so you're going to have UHD out. You're going to have another multicast for your HD feed, because most cameras want HD and UHD coming out of it. Then you have your AES, or in this case, SMPTE 2110-30 audio for your ISO mics that have to go out. There's an IP address. Then you have to do things along with intercom and those kind of things. So those are all IP addresses. So once you get those IP addresses configured, then that shows up on the network. And if it matches the parameters that the SDN is expecting, it's allowed to the network, and it can traverse from there. But that's the main setup on that.
This question is kind of twofold, and I work for a manufacturer, and this is along the lines of both a question for the group openly, and then also just kind of all around templates, okay? So as we're looking at this new ecosystem way of doing something that in the past has been very linear with SDI, it seems like there's a lot of ways to use things as an edge device and to take a signal that might have ended somewhere before and now send it somewhere else. And it's no longer an end of the road. Now it's potentially a place where the signals can go elsewhere or be used for other things. So from an extent of what you've worked on, such as this case study, it just seems like we're very limited in terms of ideas or templates of things that have been used and done beyond the blueprint drawings, right? So what they've tried to achieve, other than emulate the new technology with IP to do something that was linear, the question is there a place for these templates to exist, and could we start sharing these? Because, and this is the second part, can SMPTE lobby networks and basically my customers, because everybody is so scared or limited by legal to share what they've done in a way that other people can use it for a best practice or a way to sort of build upon that thinking later.
So I'll take that and you just chime on it. So there's a bunch of different organizations all working together. One of them is AIMS, the Association for IP Media Solutions. Mike Kronk will yell at me for getting that wrong, but it's and AIMS in particular has taken the role of kind of market advocacy and stuff like that, as opposed to SMPTE is really about technical standards development, and VSF is about some other things, and AM was about some other things. In AIMS, we actually have been putting together system architecture guidelines and templates, and so there was a paper came out for NAB. I'm sure we'll do a refresh over the summer heading into IBC, and we are trying to get more and more sort of typical design patterns. But that said, most of the facilities I've seen where we've built with IP are really facilities that could probably have been built with SDI, albeit at some complexity or cost. And this very much mirrors what happened when servers rolled out. You remember the first video server you got, what did you do? You made it work exactly like a tape deck, including in the protocols, there's things like, what do we talk about? Mounting files. Just like you would stick a tape in, you would stick a file in. That was the model of video servers. And it really was quite a few years for video servers to be out there before people started using them in ways they never ever could have done with tape, right? And so the same thing I think will happen with IP, that the slowest evolving part of all of these infrastructures is the people and the workflows, right? So people have a way of thinking about how they work. You can't get the technology ahead of people's ability to use it in a creative workflow. So that's, to some extent, that's a limiting factor too. Not that it's intentionally limiting, but it's just, at the end of the day, we're making television, and it's a creative process, not a technology process. So there is a little bit of a limiting factor there as well that just keeps things from evolving too quickly, thankfully.
Just to pick up on that point a little bit, it was interesting in our experience with remote production, because in many ways, when you talk about at-home production or remote production, as we tend to call it in Europe, there wasn't really a blueprint for that before. So certainly my experience with that is that we all, 4 or 5 years ago when we started thinking about at-home production, we thought we knew what the application was and what customers wanted to do with it. But it soon, what happened was that the customers started thinking, oh, well, I can use it for that, but what about using it this way or using it that way? And actually, I found the converse true in that respect, because there was no sort of blueprint or way in which we used home production before. People almost had a blank sheet of paper and were actually more dynamic and much more aggressive in a way of saying, okay, well, let's try this with it, let's try that with it. So I think there is a dichotomy there that for as you've said, that for there is a desire to replace existing workflows with what we know, but on the other hand, if we don't know about it, there is a big appetite for trying to do new stuff and introduce things and workflows in ways that we've never even thought of in the past.
Well, I think that adds to the discussion about flexibility, whereas certainly the IP world is going to be and is already more flexible than a strict confined SDI type of workflow.
Yeah, absolutely.
I mean, we went through the same thing with let's call it file-based workflow. It was literally a tape replacement model, but it's far from that now, and it just took time and some very brilliant people out there to think about new ways to do it, present it to events like this, and the momentum just begins to build.
Also try to set up your projects a little bit different, not like in the past where you said I have one project This goes on for 1 year, then it will be in operation, then it's done. Those projects, when we go to all IP, they never end somehow. Those workflows, they change constantly. We cannot really define. We see this a lot with our customers. At day one, what they actually expect a month later. It evolves over time. It changes so often. It's also our job to make sure that whatever they invest in, they are still so flexible enough that they can change over time, and they are not locked in whatever technology or workflow or format. It's part of it. Sometimes not so easy to discuss with procurement that a project is not a project anymore that starts here and ends there. You cannot also split in different phases. It's just evolving over time.
Right.
I've got a training question that relates to what Thomas was talking, but also what Robert brought up about how there are fewer engineers. And of course, Carl this morning was talking about how important, how the IP Roadshow is designed for training. So you have fewer engineers. Engineers who are IT don't know the production workflow, and then you've got production-oriented people that know SDI and have to get trained in live IP. We have a model that we've all used for a dozen years or so with remote desktop, and you'd find with file-based workflows like editing and MAMs and cloud-based, well, local clouds and so forth. So you'd connect to a technician who is an expert, say, on a harmonic file server, or you get someone from Avid to help you with interplay and so forth. They would connect and walk you through it. So this goes back to Thomas. How would we work to find a technician who's not experienced with it, identifies the problem or an area of the problem, then gets someone from the vendor online? That gives, to amplify the number of technicians you have available to solve a problem.
Generally speaking, what we do is we try to split operations away more from engineering than it was probably the case before. So there's the operation layer. We try to give them tools as simple as possible. They don't have to know a lot about the underlying technology. That's the goal when we deliver a end-to-end monitoring solution or some control solution on top of that. And then you have the other part, which is engineering. There are some specialists you have to have internally, but certainly you will need a lot more help from manufacturers as well. And those platforms, those monitoring orchestration platforms, it will be key in the future that you can expose some of the metrics you get, some of the information also to third parties. So in the past, there was almost no way when you called Cisco and said, hey, I have an issue with my switch. So if you were lucky, they could get some remote access, but probably only to the Cisco device. They had no idea about any source or destination which was connected to. But now to troubleshoot as a Cisco engineer, you also need access to those devices. You cannot troubleshoot just with your own device anymore, and there must be ways to share such data also with third parties in the future.
Well, that's always been the problem. You don't have one throat to choke, although you'd like to. Avid is a perfect example in terms of how they work as an enterprise. Even with an Avid, and no dig on Avid, it meant by this, but with my experience over the years, running with an interplay deployment and using ISIS, for example, at one point there were 4 technicians that had to get on the phone within Avid to talk about a problem. We'd conference in, 1 or 2 would actually be working via remote desktop just to solve that problem. And it was file-based, so it wasn't even real time, and we had some time to solve the problem, or we had workarounds. So how would we work in a live, real-time environment, as we're describing here, to troubleshoot and get the right people on the phone or online at the correct time to solve the problem as quickly as possible?
I think you can fix part of that commercially. This is not solely a Grass Valley solution. I know there's other vendors doing that, so I'm not just trying to plug us. But there is a solution you can do commercially where you can say, hey, Grass Valley as an entity and Cisco as an entity, we realize that we're going to work together on this project. And we realize that it's going to be our products on the edge and our control system, but the core is going to be a Cisco solution. What we never want to find ourselves in this spot is our customers are saying, hey, I got a problem in real time. I have them off the air or media flows aren't working. And you call Grass Valley, hey guys, you got a problem. Can you fix us? Our guys get in, we get in the system, then all of a sudden we realize, this is actually a Cisco problem. Call Cisco. We're out. And then all of a sudden the Cisco guys get in and they do their thing and this is actually looking like it's a Grass Valley problem, so go call Grass Valley. we never want to find our customers in that position, because that is a failure. So we've done some commercial work, and again, I know other vendors have done this also, which is a fantastic idea that says if you buy the solution from Grass Valley, architected by Grass Valley, and you have a problem, you call Grass Valley. And if it turns out it's not our problem, we don't just pitch it back to you to call Cisco. We have the commercial arrangement with Cisco that our service techs call them, get them in the system, working on it. We work on it internally, and then we deliver you the solution. And that seems to be a pretty good way of doing it. And I think it actually opens up, especially on for the guys like Diversified and their SIs and stuff, that could even open up, and this is just conjecture, and my apologies for playing in your sandbox a little bit, but I think that actually opens up a lot of opportunities for them to step up and maybe find additional value stream too. Since you guys understand the Cisco world, you understand the Grass Valley world, you understand the Imagine world, there could be a play there also. So we're finding creative and new commercial models to fix that, so you as a customer are never stuck in the middle between multiple vendors trying to find a solution.
Yeah, it's very much the case that, on the one hand, as a customer, you'd like to take the commercial leverage opportunity to split your project up into 27 small RFPs and ask each vendor to do one little piece. And we certainly have customers who do that. Our experience as an automation vendor for years and years has been, that's all well and good, but ultimately when, the playlist says roll clip and nothing happens, they call the automation vendor. And the automation vendor then has to figure out, okay, yeah, we sent this command to that deck, and the deck said, oops, sorry, and so now, at least we can narrow it down. And, being the automation vendor wound up in real time for years and years being the first phone call of anything that didn't go the way you hoped, and then we have to help sort it down from there. In these routing systems, very much that's become part of the control system vendor. If you're, if you have Convergent, you call Grass. If you have SDNO, you call us. If you have the yellow and black one, you call them, I guess. And that kind of becomes the first waypoint of my IP system isn't doing exactly what I hoped. And then, yeah, we have commercial arrangements with the switches we support. In our case, it's Cisco, Arista, and Brocade that we support, meaning our service teams have those in their racks. They know how to chase it. We know how to co-open and co-close tickets and propagate things and so forth. Grass probably has the same arrangement with roughly the same vendors. It's, that's part of the gig. So when you buy a system, you can't think in the old hardware procurement model that I'm buying a box, you deliver a box, I pay my invoice for the box, and we're all out. We can't sell it that way. You shouldn't buy it that way. It's a more longer-term relationship because you need the supportability. It's not a model where your third shift maintenance guy is going to know how to solve everything that could possibly happen. So we have to be ready as vendors to support our end of it, and we have to find commercial terms and commercial solutions that allow us both to have viable businesses.
What we also started about 2-3 years ago with Skyline is about having proactive contracts, maintenance contracts. It's not only that we wait for a call when something went wrong. We really have dedicated people, mostly the people that have deployed the solution, to look at the system once a day, once a week, constantly to monitor the system and to go more into a consulting role to say, okay, when you go on like this, you might run into an issue here. I see something is not perfectly right there. To avoid a couple of things before they even cause big trouble. And that's more about having frame contracts as well with the end customers, but also together with some manufacturers, because we cannot do it on our own. As with Dataminer, we are just a software company. We don't have any other hardware, software to control. We rely heavily on our partner network to do that, and then we have to work together on that. But it's more and more about these preventive maintenance contracts and deals we are doing with the customers.
But you didn't answer the question, and I'm going to frame it a little bit differently. All of you guys are manufacturers or integrators, and ideally it's one-stop shopping, everything Grass, everything Imagine, everything whatever, but it doesn't work that way, and particularly if you're not doing a greenfield build, there's stuff. And just saying that, you own it all, and the question was about training. So everybody here in the room wants to know how they get the knowledge, understanding new topologies. Orchestration is terrific. you need orchestration. How does the orchestration layer into the topology? How do you learn about the topology that's necessary? Somewhere during one of the breaks, it came out that NMOS is its own server, which essentially is an SDN layer within the new topology of communication and integration of all of these systems. And I think what Rick was saying is, how do you take the knowledge of what's being put together right now in pieces and somehow
How did you do it
demonstrate the
historically?
topology and train people on what that is in a more open way that's not manufacturer specific?
How did you do it historically?
Line drawings, the documentation's changed. Gary wrote a very interesting article in Broadcast Bridge, I think, 2 years ago. Oh, go ahead.
Oh, you.
I'm sorry. Gary Olson, who was just asking the question, is a columnist in Broadcast Bridge, and I think it was 2 years ago he wrote an interesting column about how documentation must change for this IP workflow environment. And we always had pieces of it. I was talking earlier about my experience with the A company, and it wasn't just A. They had bought Sundance, and we had Sundance Automation, and we had Airspeed servers that we ultimately replaced. So the point of it is that it was really a collection of companies under one umbrella, with people who on the call, how do we introduce each other to themselves to one another, even though they all worked for the A company. So, and again, it's just something that should have worked. We had SLAs for all of these products and paid a huge amount of money. I think in excess of $60,000, $70,000 a year just for the maintenance contract for updates, which we rarely got, because if we put them in, we would have to be prepared to be down because it would always not work, because every system is so different. And the other part of it is that, so we're paying that just for this opportunity when things went wrong to get back up. For example, the SQL database, the original Sundance was like 5 monolithic boxes that talk to one another. So it was extremely fragile. Any one thing could happen, and you could generally figure out what went wrong. And there were, of course, a lot of SDI components, but that was not the stuff that would go wrong. The legacy control, the 422, the VDCP, it was generally database or something that's happening under the hood. More times than I can remember, it was something corrupt in the SQL database that worked with the Sundance playout. So my point is, that's a case in point. That's how to answer your question, we documented it in a way of line drawings and tables of IP addresses and so forth. But I don't know what we're supposed to do now.
I think to address your statement directly, anytime you have a very complex anything, in this case, a very complex solution, the first step to diagnosing that is to break it down into smaller, more digestible parts. That applies on training. So if you have a solution that's going to take SDI and baseband and PTP and SDN and media flows and multicast and unicast, if you just address it as one big holistic solution, it's going to be too much for one person to learn in one period of time. But if you break it down into smaller training elements, hey, I need to go get a CCNA because I need to understand what unicast and multicast and media flows are over leaf-spine network. There's a training element. Great, so now I got that fundamental. So now what traffic is on that solution? Well, I've got PTP. Well, Tech has some fantastic stuff on PTP. Other companies like Meinberg has fantastic training on PTP. Same on SDN, whether it's a Grass Valley solution, we have training available for ours. I know Imagine has training available for theirs, and all the other gentlemen do too. So you can take this complex solution, break it down into smaller, easily adjustable parts, and do the training from there. I think that's kind of how we've had to do it.
That can help with troubleshooting, but how does it help you actually fix the problem? You still need someone who's a specialist who works with this, 5 days a week. When you're an engineer in a facility, and there are fewer and fewer engineers with more and more responsibilities, they're lucky if they could just locate it on their in their documentation.
Yeah. I mean, there was a point years ago when facilities were built with analog and they had enough engineers that those engineers were all trained and had specialties, and you really could self-sufficiently keep your facility on the air pretty well. And those days have elapsed. Independent of this IP transition, I've just seen in most of our customers, there's fewer and fewer engineers covering off on more and more things, to the point that they are, and we've become as an industry pretty reliant on the vendor base to, help get involved in problems that years ago probably would have been fixed by trained staff. And that's just what I see. I mean, I'm not assigning a goodness or badness to it. Maybe it's bad on us as vendors to have enabled that, but that's how it's kind of gone. it is a challenge moving forward. How do we, do we return to the good old days where every broadcaster had enough internal engineers who were so well trained that they could just fix things on their own? Well, that'd be great, but it doesn't seem very realistic.
Unlikely to happen.
In most systems, it's going to be a balance of getting the in-house staff trained well enough to address, the first 50% of things that happen, and maybe early in the project it's 20, later it gets 30, 40, 50%, and having SLA agreements with your major vendors to cover off on the rest. It's some combination like that. But it has to be a combination of industry training, specific product training, SLA agreements, and the whole thing. It's commercial arrangements as well as technical to get to working facilities as it is today.
When you look at those platforms, monitoring, network management, and all of that, there's one goal also to bring people together with those platforms, to have the same platform, whatever it is, in multiple groups. They should all use the same. But as we have just seen, those platforms ideally, and that's our goal as well, they can show you the root cause of an issue. If it's an issue that you can repeat, you can also automate it to a certain level to fix it, but very often you need still a specialist on it. But at first stage, what we do with data miner, what other network management systems are doing, we try to find the root cause of the issue. And then you can at least call the right guy, and it's a Cisco issue, it's an issue on the edge device, it's something else. Then you have already won a lot of the whole game. It's still not solved, but then you might need the specialist. At least then from that point on which specialist to call. Can be an internal one or external?
Sorry, I think
Yeah,
we still avoided the question that I'd asked you guys and you asked me again, was in the old days we had line drawings that explained and informed us on how all the boxes work together. Now we have a bunch of applications, so what's the replacement for a line drawing? So a technician who not just knows IT and has a CCNA certification and so forth, sees the production workflow and understands how all these applications work together. I've never seen a document that shows me that in any facility.
I've never met a person who knows all of that, so I don't think it's replicable is the point.
Well, some of the orchestration systems are very dynamic. I mean, you're talking about a system that potentially could change from one production to another, to the next production, and all of the flows could be managed in a different way. So there are dynamic solutions right now. Maybe some of you have seen the screen diagrams where the rubber bands and you move things around and flows change and so forth. That's going to be a tool that the facility maintenance folks are going to have to learn to use. With that goes things like data collection, where you can start to look at trends in your system. It might be that a switch works just fine until you get to 9.2 gigabits, where it normally runs at 9, but at 9.2 something happens. That's got to be data that's collected over time so that there can be some predictive analysis of what might happen. One of the examples is that video server manufacturers 10, 15 years ago would literally keep that kind of data in their system, and if you subscribed to that manufacturer's service SLA, this before the use of SLA, but they would actually come out and say, your drive number 4 is about ready to fail, you better replace this. You'd get an email or a notification like that. That may be part of the solution to managing these systems in the future. I think there's all sorts of combinations here that are going to evolve as facilities come online and as people give feedback to not only the manufacturers and the SIs, but to the rest of the user community.
So I think I can also probably give a little bit of focus to this, because we've run into this problem at the library where we've got a hybrid system where we've got audiovisual systems that are heading in this direction, but we've also got large-scale enterprise IT systems that are multiple applications using multiple networks, talking both at the physical layer and the software layer. And part of what I think you're asking, Rick, is how do you do a traditional line drawing for things that have software relationships? Am I correct?
First place you're going to go to start to identify where you can start to look.
So So the way that we've done it at the library, and I have a feeling that we're probably going to be talking about something like this from a documentation perspective, and probably from a training perspective as well, is you have line drawings that are not traditional line drawings. First of all, you've got the physical layer drawings that show you how everything is connected to each other. But of course, when you've got network switches involved, there's multiple things going on each of those connections potentially in any moment in time. And so what our enterprise IT folks have done is they have created line drawings, quote unquote, that show the relationships between the different software packages, software layers, firmware layers that are talking both at the protocol level and at the information interchange level, showing if something is queuing off of another piece of software or is waiting for a clue or is waiting for feedback coming from a device saying that I've got a drive in my SAN that is failing, because we've got SANs that tell us when their drives are failing. And, you know, in the traditional sense, that would have been somebody getting an email or, you know, a page saying something's wrong with your SAN, go and look at it. But now that's going to be much more automated, because instead of that going to a human, that's going to go to a system that will clue the humans into what's going on, and will be at a management layer level that will say, you've got, you know, different things going on in different parts of your network. Here are the issues at hand today. And so I think we're probably going to be heading in something like that direction, where it's not just the physical layer line drawings, but it's the software interchange line drawings as well, that shows how things communicate with each other, and, you know, what kind of handoffs that they do, and also how health and welfare information is collected and given to the people or systems that need to aggregate it and act on it.
I have a really. Is this on?
Go a little bit further.
I have a really quick, banal question that can probably be answered with yes, no. Is it okay to run a 2110 network on a VLAN, because the hardware, the topology looks very similar to a post-production network, storage network topology? It would be tempting to maybe have that traffic being on one VLAN and live production traffic on another. Cool? Yes, no?
Yeah, run it in a VLAN, sure.
Yep. That's what you
Well,
see.
you have to set up the VLAN correctly, but yeah.
That was it.
Yeah, that IP
wait,
kit
he's talking about a VLAN, not a VPN.
VLAN, yes.
Not necessarily.
I think we have time for just one more question, because we have the Evertz-sponsored afternoon break coming up. Any takers? Sorry? I know I'm way over, so I'm saying. Then why am I even hedging? Because I think it's such a good conversation, that's why. We're going to have to wait till next year to do this again.
Your VLAN has collapsed.
All right, then go get them. The Evertz afternoon break lunch is now serving. Thanks, guys. That was great.